Okay, we will start with the linear inequalities. Linear inequalities. Linear means it's x to the first degree. Notice that we have x to the first degree right here. When we solve this inequality, we start by adding 7 to both sides. We'll get negative 2x is less than 16. I divide by negative 2, and what do? Why? Why do we flip the sign when we multiply or divide by a negative? You've always just been told to do it. Do you know why? Let's look at the basics. Is 1 less than 3? Yep. Now I'll multiply through by negative 1. Is negative 1 less than negative 3? No. Just because the way our number line is set up, if you look at the numbers in terms of increasing and decreasing order, it would seem that, negative 3 is greater than negative 1. But no, negative 1 is greater than negative 3. So you can see how that kind of works there. Okay, so if you multiply or divide both sides by a negative, switch the sign. I know these are things that you've seen before. This is a little bit of review. The fact is that people do forget to do these things on the test. Graph the solution set and write it in interval notation. You now know from our first test that we can have answers expressed as an inequality. We can have them expressed as a graph. And we can also have it expressed, as an interval. The interval would be -8, infinity. That would be my interval. Are you good with expressing the answers 3 different ways? Is it okay with you if I say that on our test and whatnot for that unit, I would want interval notation? That's my preferred avenue. We're all okay with that? Okay. Compound inequalities are inequalities that have more than one part to them. So 2 or more inequalities. This inequality here is called a conjunction. Conjunctions are ones that come together like this. Okay. And I like to separate it as -9 less than 3x minus 7, which is, and then I do another one. The second inequality is 3x minus 7 is less than or equal to 11. See how I extracted 2 inequalities? The inside is shared both with the outside and the other outside. So now I solve. I add 7 to both sides, and I get -2 is less than 3x. Divide by 3. Do I switch the sign? But I'm dividing a negative. You're not dividing by the negative. Okay? There's a common mistake that people make. -2/3 is less than x, or you could write x is greater than -2/3. However you'd like to write it, those are the same. The next one, I add the 7. And I get 3x is less than or equal to 18. Divide by 3, and I get x is less than or equal to 6. So, if you were to write this as a true inequality, you would write x is greater than -2/3 and x is less than or equal to 6. The way that the book would write it and I would write it is -2/3 is less than x, which is less than or equal to 6. That is truly the conjunction, the representation of the inequality in one format. How I will ask for the answer on the test, I'll ask -2/3 and I'll ask 6 in a bracket like that. Again, I would like interval notation. We good? Try the next one on your own. This is a disjunction, meaning that they will go apart from each other. So see if you can quick solve that and come up with a solution set. I have x greater than -2, x less than -5. When people try to work through these, it's common for people to put the -5 there and -2 there. Is that correct? Why? Yeah, so it's -5 and -2, and you can see that the arrows go this way. It's a disjunction. It's an or statement. So you would have the interval notation would be from -infinity to -5, union 2 to infinity. So remember from our first unit, as we talked, or first lesson we talked about that union set as you're joining two pieces together. That's what you do. We good with that? Okay. How smart are you guys? Like really smart, kind of smart, not smart?
Depends on the topic.
Did somebody here say average? You said average? You guys are really smart. Let's try this. Absolute value inequality. Suppose I have an absolute value. Like you have the absolute value of x is less than 6. Yeah, exactly. You split up into x less than 6 and x greater than negative 6. So what I want you to see from this situation is if you end up with a less than, I think of it like this. See if somebody taught you this. Less than. Anybody ever teach you that? So when I have an absolute value and I see the less than, I think and, which means conjunction, that they should come together like so. Okay, so we'll be able to predict what type of solutions we should get based off of the setup of the inequality. Okay, and if you get greater, then it would be like this: great or greater than. See how it's greater than? So it'd be an or situation. So they would go away from each other. See that? Okay. So let's try a problem right now. Let's try letter A. So I'm going to solve this. We're going to try to predict ahead of time what we're going to get. Absolute value inequalities. Just got to like wave your hand at me. Say, hey, Mr. Gens, I didn't get anything yet. Hey, Mr. Gens, I don't want to interrupt your class, but I'm going to because I'm concerned about my learning. Yeah? There you go. Okay. So what should I do first? Add the 9. Good. Because some people don't do that on the test. You just start taking off the absolute values right away. You're all reckless. Don't do that. Okay. Greater than 30. Great. Is this going to be a less than or a great or? Everybody see how it's great or? So they're going to go apart from each other. It's a disjunction. See how we know that right away? So I set up 2. I have 2x minus 3 is greater than 30. What's my other one? Good, good, yep. Now we're just going to be careful. We're going to add that 3. 2x is greater than 33. Divide by 2, x is greater than, I'm going 16.5 on that. And the next one, I add the 3, I get 2x is less than negative 27. Divide by 2, x is less than negative 13.5. So are they coming together, or are they going apart? What do we decide? They're definitely going apart. Okay, so if you look at it, we got greater than 16.5. So open circle that way. And then less than negative 13.5. So open circle that way. So we knew that from the beginning of the setup. If we express this in interval notation, negative infinity to negative 13.5, union 16.5 to infinity. And there's our solution set. I don't think so. We don't really have too many, we shouldn't have inequalities on this test. Do letter B on your own. Try letter B on your own. Is there a question back there? I was wondering what the big deal was, but now that I've had foot problems, I get it. Absolute value of 3 minus x is less than or equal to 5. So I set up 3 minus x is less than or equal to 5. And 3 minus x is greater than or equal to negative 5. So notice you had to switch the sign there. As you subtract the 3, negative x is less than or equal to 2. Divide by a negative x is greater than or equal to negative 2. A lot of switching of the signs, isn't there? Then in this situation, we subtract 3. Negative x greater than or equal to negative 8. X less than or equal to 8. So greater than or equal to negative 2 arrow goes that way, less or equal to 8, arrow goes that way. It should be plain to see that the solution set is negative 2 to 8. Is that what you got? One of the most common problems that people get wrong on the next test. And you're saying, but I can do that. But we do make simple mistakes from time to time, don't we? Okay, so let's try to avoid those. All right, let's try to understand some kind of odd situations. If you end up with a 0 or a negative on the other side, we got to do some like thinking. Absolute value greater than a negative. I want you to think about that. If you take the absolute value of something, like my daughter Tenley, she's 6th grade, she doesn't really know anything yet, right? If you're trying to teach Tenley what absolute value means, what would you tell her? Can't be negative, it would make it, the absolute value of anything makes it positive, right? That's a good place to start, right? Take the absolute value of a number, just make it positive. Well, think about this. If you saw an expression that said absolute value that's greater than a negative, is a positive always greater than a negative? Yeah, so you don't even need to do any work there. You just say all real numbers. So negative infinity to infinity. You're done. If you see a 0 or a negative, think it out. Don't try to work it out. Think it out. Can a positive be less than a negative? No. So what would my answer be? No solution. Could an absolute value be less than 0? What kind of numbers are less than 0? Negative numbers. So does that would that have a solution? No, no solution there. Okay. What's different about the next one? Greater or equal to, right? An absolute value can be equal to 0. So here you just have one solution. In that situation, yes. Absolute values are always positive or 0, right? So if it says an absolute value is greater than or equal to 0, any thoughts? All real numbers. And then what about an absolute value just greater than 0? All real numbers except for just one spot, right? Yeah, this excludes one value. So I'll show you an example, okay? Look at letter C. Suppose you were to solve letter C, what would you do to both sides? You divide by 6, okay? And you get the absolute value of x minus 5 is less than or equal to 0. Uh-oh, Mr. Gens said if you get 0 or a negative on the other side, you should think about it. Can the absolute value of something be less than 0? No. Could it be equal to 0? Yes, we just get one solution wherever x minus 5 is equal to 0. What do you get? 5. And if you're ever wondering about your solution, what could you do? You could plug it back in. 5 minus 5 is 0, times 6 is 0, and that is less than or equal to 0. So we're good. Hannah, give me a number. Any number you want. 8. So we're saying that x is 5. We're saying x can't be 8, correct? What's 8 minus 5? 3 times 6? 18. Is 18 less than or equal to 0? No. Doesn't matter what other number you pick, it won't work. That's the curiosity. When you check your answers, that's very helpful. What do I do the next one? Yeah. Uh-oh, Mr. Gens told me that if I get a negative on the other side, that I should think about that. This is saying an absolute value greater than a negative. What? But I thought an absolute value couldn't be negative. It's always going to be bigger, right? It is positive. Yep. Positive is greater than negative. All real numbers. Don't need to do any work. Good? Okay, last little bit. We need to talk about quadratic inequalities, nonlinear ones. You had this last year. You don't remember it as well as you hoped you would, okay? You need to kind of erase from your brain any thoughts that you had about how this worked, because people tend to make mistakes with it. They're like, oh, I thought you just did this. No, you don't. Okay? Look at what we have here. It says x squared plus 2x is greater than 15. Okay? Give me a number. 7. 7 squared is 49 plus 14. Is that greater than 15? It is, isn't it? So it turns out that 7 is part of the solution set. Give me another number. 5. 5 squared is 25 plus 10. Is that greater than 15? So 5 is part of the solution set. Give me another number. Make it 1. Let's try 1. 1 squared is 1 plus 2. Is that greater than 15? No. So 1 is not part of the solution set. It would take a while to test to see all the numbers that it works for and doesn't work for. Agreed? So we have 2 methods by which we can determine this. Number 1, we can do a number line test. Very useful. Did I? Numbe. It's not English class. All right. I'm going to subtract the 15 over and get x squared plus 2x minus 15 is greater than 0. And I'm going to factor it. It factors to what? Plus 5 minus 3. So what are the numbers that make 0 then? Negative 5 and positive 3. So I'm going to go to my number line and I'm going to write down negative 5 and positive 3. Those are the numbers that give me 0. Understand that we're working with an inequality, things that are greater than 0 or less than 0. Here's where it's equal to 0, okay? And watch what happens now, okay? Watch what happens. Let me rewrite that so we can see better. All right, Mikey, give me a number that's to the left of negative 5. Anything to the left of negative 5.
Negative 21.
Negative 21. Negative 21 plus 5. Is that positive or negative? It's negative. Negative 21 minus 3. Positive or negative? Negative. And a negative times a negative is a positive. It doesn't matter what you plug into the left of negative 5, you're going to get out a positive value. Trust me, you will. Let's try a number between negative 5 and 3. What number between negative 5 and 3? It's one of my favorite numbers in the world. 0. Let's try 0. 0 plus 5, positive or negative? Positive. 0 minus 3. Negative. What's a positive times a negative? So every number you try between negative 5 and 3 is going to be negative. Right? That was Maya's number. She picked 1. 1 was between negative 5 and 3, right? And it was negative. It didn't work, did it? And then we try number 2. Here we went. Oh my gosh. All right, so a number to the right of 3. 4. Let's try 4. 4 plus 5 is? And 4 minus 3 is? And a positive times a positive is? A positive. Now, here is the important part. Are you wondering where this is positive or where it's negative? Are you wondering where this inequality is positive or are you wondering where it's negative? Why? Because it says, where is this greater than 0? See that? That tells us we're looking for the positive part. So the answer is from negative infinity to negative 5, union 3 to infinity. Can I show you an easier way? One way is to make a number line test. The other way is to make a graph. I'm going to go ahead, make a graph. On that graph, I'm going to plot negative 5 and positive 3. You guys are super smart. What does the graph of x squared look like? What shape does it make? Parabola. Right side up or upside down? Right side up because it's a positive x squared, right? So I'm going to draw a right side up parabola that goes through negative 5 and positive 3. Am I above the x-axis or below? Above. So does that mean it's positive or negative? It's positive up here. Am I above or below here? Below, so that's negative. Above or below here? Above, so it's positive. So you see how we found where it's positive by doing that, just sketching the graph quickly? Which way do you like better? Then let's do the graph. X squared plus 2x minus 8 is, or minus 8 is less than 0. Factor, what does it factor to? Plus 4 and x minus 2. Excellent. So I'm going to make the graph. What numbers do I put on my graph? Close. Negative 4 and positive 2. Does this go right side up or upside down? Right side up. It's a positive x squared. Is this positive or negative? Positive because it's above. Negative because it's below. Positive because it's above. Are you wondering where this graph is positive or are you wondering where it's negative? Why? Because you're wondering where it's less than 0. So your answer is from negative 4 to positive 2. Yeah.
So if it's actually greater than we state the infinity sign, we use infinity sign, so if it's less than we state the 2 points.
As long as it went right side up. Now, I'll show you here, is this one right side up or upside down? I don't really like to work with upside down ones. What could I do to make it so it's right side up? Times by a negative. So I get 2x squared minus 7x plus 5. Switch the sign, greater than or equal to 0. So that allows me to look at the positive graph instead. Does it factor? Yeah, 2x and x. Good, minus 5 and minus 1. Atta boy. So what are my solutions? What numbers do I plot on the graph? 1 and 5 halves, which is like 2.5. I don't look at the original. I look at the one I set up for my factoring. It was right side up or upside down. Right side up. And we already talked about, it's positive where it's above, it's negative where it's below, it's positive where it's above. Are you wondering where this one is above or where it's below? Above. And that would be from negative infinity to 1. Bracket, because we have the equal sign. Union with 5 halves to infinity. Good job. So you do not have to have this assignment done for your test. This is something that you'll work on later. If you'd like to start on this, go ahead. If you'd like to work on stuff from last unit, study guide, that's fine. Tomorrow you get a full work day. Okay. There is one problem I want to practice with you right at the beginning of class because I want to make sure you do it correctly on the test, and that's that.
Question.
Sir.
Question really on this